Every black hole hides a secret that turns everything we know about space and time upside down. For decades, we've known that black holes devour matter, energy, and even light itself. Nothing escapes their gravity. But what if there were cosmic objects that did the exact opposite? Not swallowing everything, but spitting it out. This is the riddle of white holes, one of the strangest and most mysterious ideas in modern astrophysics. A white hole is the theoretical mirror image of a black hole. Where a black hole traps everything, a white hole expels everything. Where one consumes, the other rejects. In Einstein's equations, the mathematics that describes a black hole also allows for the existence of its opposite, a region of space-time that cannot be entered from the outside, but can eject matter and light freely. To understand how bizarre that is, imagine a cosmic fountain, one that sprays out light and energy, but never lets anything fall back in. That's a white hole. If black holes are the ultimate prisons of the universe, then white holes are the ultimate escapes. But there's a problem. We've never seen one. So why do scientists believe they might exist? It all began with Einstein's general theory of relativity, a masterpiece of mathematical beauty that describes how gravity curves space and time. In 1916, physicist Karl Schwarzschild discovered the first exact solution to Einstein's equations, the one that describes a black hole. Decades later, scientists realized that this same solution had a mirror version, one that described a time-reversed black hole. That time-reversed version behaved like an object that nothing could enter, but everything could leave. A white hole. According to relativity, every black hole solution has a corresponding white hole solution. They're two sides of the same cosmic coin. But here's where the paradox begins. If white holes exist, where are they? Why haven't we observed a single one in the sky? The reason is simple. They shouldn't last long enough to be seen. Anything ejected from a white hole would instantly collide with matter outside, creating catastrophic explosions and collapsing the system. In the modern turbulent universe, a white hole should be destroyed almost as soon as it forms. That's why for decades scientists treated them as mathematical curiosities, elegant but unreal. Until now. New theories are changing that. Some researchers believe that black holes and white holes might actually be connected, not separate objects, but two ends of the same process. According to this idea, a black hole doesn't destroy what it consumes. It stores the information, then releases it elsewhere through a white hole. If true, it means that what falls into a black hole in one region of space-time could be expelled through a white hole in another, perhaps even in another universe. In other words, black holes could be gateways and white holes could be their exits. This concept ties directly into one of the biggest mysteries in physics, the black hole information paradox. Quantum mechanics insists that information can never be destroyed, but black holes seem to erase it completely. White holes could be the answer. They might be how the universe preserves its memory, releasing everything that black holes swallow, not instantly, but over cosmic timescales. Imagine it. Every black hole we've ever observed could one day turn inside out, transforming into a white hole and returning all the matter and energy it once devoured. It's a mind-bending idea, but it's not pure fantasy. In 2014, physicist Carlo Rovelli proposed that when a black hole shrinks due to Hawking radiation, it could eventually collapse into a quantum bounce, a moment when the structure of space-time reverses itself. Instead of ending in a singularity, it rebounds, expelling everything as a white hole. If this is true, it could explain many cosmic mysteries. The bursts of high-energy radiation that astronomers detect from deep space, those sudden flashes of light that appear and vanish in seconds, might be white holes revealing themselves for an instant before fading again. They could be the universe's way of breathing, inhaling through black holes and exhaling through white ones. And that changes everything we thought we knew about time itself. In the realm of relativity, black holes are regions where time slows almost to a stop. To an outside observer, anything falling into one seems to freeze forever at the event horizon. But if that process reverses, if a black hole can become a white hole, then perhaps time can flow backwards as well. A white hole may not just be an explosion of matter. It could be the mirror of the past. That possibility has made scientists rethink one of the deepest assumptions about the universe, that time only flows in one direction. Maybe what we call the future and the past are connected through these cosmic mirrors, folding into each other in ways our minds can barely comprehend. The idea is as terrifying as it is beautiful, because if white holes truly exist, they would mean the universe isn't just expanding forward, it's constantly reflecting, rewriting, and remembering. Every action has an echo. Every collapse has a rebirth. If you've been following this journey so far, take a second to subscribe to Know Your Sky. What do you think? Could white holes be real, waiting to reveal themselves when the universe is ready? Share your thoughts in the comments. Your ideas often shape what we explore next. Now, let's go deeper into the paradox. If black holes and white holes are connected, what lies between them? The answer might be the most mysterious structure ever imagined. The Einstein-Rosen bridge, better known as a wormhole. A wormhole is a tunnel through space-time that could, in theory, connect two distant points in the universe, or two different universes entirely. Mathematically, it's possible for the entrance of a wormhole to be a black hole and its exit to be a white hole. Matter falls into one end, travels through the tunnel, and emerges from the other, perhaps at a different place or even a different time. No one knows if wormholes are real, but they fit perfectly within the equations of relativity. And if they are real, then white holes might be the key to finding them. Imagine a galaxy somewhere far away, where a star disappears into darkness, and in another part of space, light suddenly erupts from nothing. The two could be connected, one world losing, another gaining, one end devouring, the other creating. It's not just poetic, it could be physics. Some researchers now suggest that the entire universe might have been born from a white hole, a cosmic eruption of energy that began time as we know it. In that sense, the Big Bang itself could have been the ultimate white hole, the universe's first exhalation. If that's true, then we are living inside the greatest white hole of all, a reality that began with pure release, expanding ever since, carrying with it the memory of what came before. And maybe when the universe ends, it will collapse into a black hole again, only to bounce and begin anew. A universe that breathes in and out for eternity. If white holes exist, they would be the most extraordinary objects in the universe. Windows not into darkness, but into creation itself. They would be regions where time runs in reverse, where entropy decreases instead of increasing, where the universe gives back what it once took. And yet, everything we know about physics says they shouldn't exist at all. To understand why, we have to look at what keeps the universe moving in one direction, the arrow of time. In our world, everything flows forward. Stars burn out, people age, galaxies drift apart. The second law of thermodynamics tells us that entropy, disorder, always increases. It's what gives time its direction, but a white hole would defy that rule completely. It would be a region where entropy runs backward, where things move from chaos to order, where light and matter that were once trapped suddenly reverse their fall and erupt outward. If a black hole is the ultimate end, a white hole is the ultimate beginning. Theoretically, a white hole could form when a black hole collapses beyond the quantum scale. As it evaporates through Hawking radiation, its mass and energy shrink until quantum gravity takes over. At that moment, the collapse could bounce, reversing itself like a cosmic spring, recoiling from infinite pressure. The result would be a white hole, a rebirth of everything the black hole once consumed. This idea isn't just mathematical fantasy. Researchers like Carlo Rovelli and Hal Haggard have proposed that the universe itself may be littered with such objects, ancient black holes that have already completed their transformation into white holes but remain hidden by time. Because time flows differently near black holes, what seems like billions of years to us could feel like an instant inside. From the universe's perspective, these transformations could already be happening. We're just too early to see them. Some astrophysicists even speculate that mysterious cosmic flashes, sudden bursts of high-energy gamma radiation, could be brief glimpses of white holes opening for fractions of a second, releasing their stored matter before fading back into silence. If that's true, then we may have already witnessed white holes without realizing them. They might be scattered throughout the cosmos, rare, fleeting, but real. Yet, white holes don't just challenge our understanding of physics, they challenge our understanding of causality itself. In a normal universe, causes lead to effects. A black hole forms after a star collapses. The cause precedes the consequence. But in the equations that describe a white hole, that order is reversed. The effect happens first, matter bursts out, and the cause, the collapse, comes later in the timeline. To us, that seems impossible, but relativity doesn't forbid it. It only reminds us that time depends on perspective. For someone outside, a black hole might take billions of years to transform. For someone inside, it might happen in an instant. And from another point of view, a perspective reversed in time, what we see as a black hole could appear as a white hole. It's all relative. In that sense, black holes and white holes might not be different objects at all, but two aspects of the same process viewed from opposite directions in time. The idea is staggering. The universe could be filled with structures that connect the past and future in ways we can't yet perceive. If wormholes truly exist, tunnels through space-time, then a black hole on one side could connect to a white hole on the other. Information would fall in through the black hole, travel through the bridge, and emerge somewhere else, sometime else, completely transformed. That might sound like science fiction, but it's one of the few ways physics can reconcile the loss of information with the conservation laws that govern the universe. It suggests that nothing ever truly disappears, not even across time. What falls into darkness may someday re-emerge as light. Some cosmologists have even gone further, proposing that our own universe could have been born from a white hole. If the Big Bang was the ultimate eruption of energy and matter, if time itself began in an instant of expansion, then maybe what we call the beginning was simply the other side of an ancient collapse. Perhaps another universe before ours collapsed into a black hole, and we are what emerged, a white hole explosion seen from the inside. That would make every galaxy, every atom, every heartbeat part of an infinite cycle of collapse and rebirth, the universe breathing in and out through eons beyond imagination. It's a comforting thought, isn't it? The idea that endings are not final, that even the universe knows how to start again. And if you've stayed with us through these ideas, then you're part of that rare group who still looks at the night sky and feels wonder instead of fear. Take a second to subscribe to Know Your Sky and share your thoughts in the comments. Do you think white holes are real? Could we be living in a universe born from one? Your questions guide the stories we explore next. Now imagine what it would mean to actually see one. A white hole would shine brighter than any star, flooding space with pure energy. It would be chaotic, unpredictable, and yet perfectly ordered in its defiance of time. Nothing could enter it, but everything would flow outward from it. Light, heat, matter, information. It would be a cosmic rebirth in motion. Yet if one ever appeared near us, it would mean the end of everything we know. The radiation it released would obliterate anything nearby in seconds. White holes may represent the beauty of renewal, but they are also reminders of nature's power, creation and destruction as the same breath. Still, somewhere deep in the equations, the math keeps whispering that they must exist, that the universe needs balance, that for every black hole pulling inward, there must be something pushing outward. And maybe that's the ultimate symmetry. The universe forever folding into itself and unfolding again, never truly beginning or ending, just transforming. Some scientists dream of detecting one, of capturing its signature in the cosmic background radiation, or in a burst of high-frequency light. Others think the proof may already be buried in the data. We just haven't learned how to read it yet. Either way, the search continues, because white holes represent something more than just exotic physics. They represent hope, the idea that nothing is truly lost, that every collapse carries the seed of renewal. Maybe that's why these theories keep scientists awake at night, not out of fear, but out of fascination, because to understand white holes is to glimpse something eternal, the universe's ability to rebuild itself, to turn destruction into creation, to make even the impossible real. In the end, that might be the most profound truth of all, that every darkness hides its mirror of light, waiting patiently to return.